Okay, I'll start then. My name is Nick Johansson, and my thesis has been about named entity recognition on transaction descriptions. And let's get into it. This is what I'm going to talk about today. I'll start off with an introduction. Then I'll talk about my approach. I'll go through the named entity recognition models that I developed. Then I'll talk about the application to transaction categorization. And then I'll finish off with my conclusions. So, introduction. So, in 2015, there was an EU directive called PSD2, which was passed in Parliament. And in brief, this directive meant that ownership of some financial data transferred from banks to individuals. Individuals could now decide who has access to their financial data, which led to a surge in innovation and applications that was based on specifically transaction data. And one example of this is transaction categorization, which is what the team I work at Tink does. And here's an example of that, which whenever you make a purchase, you get the description coming in, as well as an amount. That description is then formatted, and based on this information, a category is predicted. It could be restaurant or groceries or etc. But why named entity recognition on transaction descriptions then? So if you look at this description, it has a couple of different components. It contains Sobares, which is an organization. It contains Ibiza, which is a location. And then it contains a little bit of noise here as well. But organizations, locations, and also persons, product, etc., these are usually some of the most important components in text. And for transaction descriptions specifically. So we would want a system that can extract this information in a structured way. And when you have that system in place, this enables further innovation and more products to be built on top of transaction descriptions. And to the best of our knowledge, this will be the first published report which does this, named entity recognition on transaction descriptions. So this is exciting. Let's continue. What is named entity recognition? It's the task of classifying and identifying named entities. And what is a named entity? It more or less corresponds to entities that can be denoted with a proper name, like names of organizations, locations, persons, products, etc. And to exemplify, we have this sentence here, which Nick Johansson does his master thesis at Tink at Vasagatan in Stockholm. The following named entities in this sentence are Nick Johansson, which is a person, Tink, which is an organization, and Vasagatan and Stockholm both being locations. And let's continue to my approach. So how did I do this? So there has been a lot of research on named entity recognitions throughout the years, just not on transaction descriptions. But for normal named entity recognition, transformer models are some of the most prominent and effective. And for Swedish named entity recognition specifically. So since there is no available data set on transaction descriptions, we have to collect and annotate the data ourselves. So we did 3,200 transactions in total of annotated data, and this was Swedish transaction descriptions. And we then applied transfer learning to pre-trained models from Hugging Face. And Hugging Face is an AI community where you can get the state-of-the-art models and the most popular models within natural language processing and other machine learning models in general. And we did this in a follow the crowd approach, where we looked at the most popular models. We tried them out, we evaluated the performance. We drew some conclusions as to why did this model work well, why didn't it work well, and based on those conclusions, we continued with trying other models, basically. And briefly on what transfer learning is, you take a pre-trained network. In this case, it could be named entity recognition on normal text, like news articles, etc., or any natural language processing network, basically. And then this first part of the network here, this represents more of a generalized language understanding, while the later parts of the network represent some sort of more task-specific and dataset-specific natural language understanding. So you reuse the generalized part, and you retrain the specific part on the dataset you have and for the task you're trying to solve. And why do we do this? It's because it's very data efficient. We don't have that much data, so we want to maximize efficiency for the data that we have, basically. So let's continue. So named entity recognition on transaction descriptions. For our entity dataset, we use the following tags, which is organization, location, person, and we have a miscellaneous tag, which in the transaction dataset is mainly payment providers, products, and apps. Payment providers being the likes of Swish, Klarna, PayPal. Products, it could be iTunes, for example. And then we use the so-called BOI tagging scheme. So if you have the following transaction description, ICA Maxi Stormarknad Västra Skogen, then ICA Maxi Stormarknad, that's an organization, Västra Skogen, that's a location. And to say that ICA Maxi Stormarknad, these all belong together, we tag it like this, which is beginning organization, in organization, in organization. And then for the same thing for Västra Skogen, we say beginning location, in location. So what makes it hard working with transaction descriptions? It's that they generally lack context. So transaction descriptions, they're just 1, 2, maybe 3 words. You can see some examples here. And for named entity recognition, if we go back to this example, Nick Johansson does his blah, blah, blah. Then you might have never heard of Nick Johansson, but you can still figure out that this is a person. You might have never heard of Tink, but you can still figure out that this is an organization. And why? Because the context tells you that this is the case. But for transaction descriptions, you can't make use of that information, which makes it harder. And then also there's no proper grammar. There are a lot of short and cut off words, a lot of noise. And then when it comes to capital letters, it's just for each first letter of each word is being uppercase, which doesn't give any information like it does in normal language. If you have names, for example, then they usually start with the upper letter. Okay, so what are some of the positives then with the Tink dataset? The Tink dataset, it has a lot of patterns. If you look at the complete tag sequences for transactions, then you can see that the top 5 tag sequences covers 45% of the dataset, the top 10 covers 66% of the dataset, etc. What does this mean? It means that in this case, for example, the most common transaction is a 2-worded organization. It could be Circle K, for example. The second most common transaction is a 1-worded organization. It could be Spotify. Third is 1 word which is not an named entity. It could be a phone number, for example. And then 4 words which is not an named entity, and then organization followed by location, etc. So the most frequent sequences are very frequent in the dataset. So that's a positive. Let's continue. So the named entity recognition models that I developed. So these are the models that I developed. I looked at both monolingual and multilingual models. And initially we did 700 transactions for training, 300 for validation, 500 for testing. And as you can see here, the last line here, overall F1 score, this is the most important score. And this is the standard way to evaluate named entity recognition. It goes from 0 to 1, with 1 being better. And then if you look at this score, then the Arbetsförmedlingen Swedish BERT model, that is our best performing model, while the uncased version of the MBERT is our best performing multilingual model. So what we do then is that what I realized when doing model evaluation was that in order for a model to perform well, then the vocabulary of the model needed to be uncased, that it doesn't take capital letters into consideration. And this was sort of what I talked about before, that that if a word starts with a capital letter, then in normal language, then it's a much higher chance of it being a named entity. It's like names of persons, names of organizations, they start with capital letters. But for the TINC dataset, then every word starts with a capital letter. So if you take capital letters into consideration, you will basically not have good results. So this was one important aspect of the model, basically. Okay, so what we do? We took our best performing monolingual model and our best performing multilingual models, and we added more data to see how it would perform. And using 2,200 transactions for training, 500 for validation, 500 for testing, then the Arbetsförmedlingen model, we get the overall chunk F1 score of 0.849, while for the MBERT, we get the 0.805. And is this good? Is it bad? There's no real baseline to compare to for transaction descriptions, but what we can do is we can compare it to state of the art for Swedish named entity recognition in general on normal language, news articles, etc. And this is the Kungliga biblioteket BERT model, which reaches an overall chunk F1 score of 0.927 when evaluated on news articles, etc. And as you can see, we're not that far off from the Swedish state of the art. And this is considering that we use a much smaller data set for training, and also our data set is a bit more messy and doesn't have proper grammar like the one that the KB model was evaluated on. Here you can see a detailed breakdown as well on per entity level. But yeah, I'll continue. So learning curves. This is something you produce when you want to see the potential of the model. So what you do is you train a model for different amounts of data, and you see how much does the performance increase with added data. And for this, the AFAI model, for example, this one doesn't really show any signs of slowing down. So you would expect to see higher performance if you add more data to the model. But for the BERT multilingual model, then this one does show some signs of starting to plateau, but you would probably need more data, annotate more data just to be sure that this is the case. But maybe you won't expect massive increases in performance for this one with added data, basically. Okay, so here are some visualized examples of named entity recognition. And so on the left here are some correct examples. Here you can see it finds the organizations, it finds the locations, it finds the persons. In this case here, it doesn't find anything when it's not supposed to find anything. And then it can also separate between payment providers and organizations in these cases. And here are some incorrect examples. And yeah, you can see here, for example, it misses 7-Eleven, which is an organization. Here you have a Svenska Spel Sport, and the sport is not supposed to be included in organization here. And the same thing for Eon Kundsupport. Kundsupport is not supposed to be included in organization here. Then you have Delivery Hero Sweden Fedora. You could argue that this is correct, but at least as I annotated it, I annotated Delivery Hero as one organization, Sweden as a location, Fedora as a separate organization. And then you have Kolmårdens D, which is supposed to be Kolmårdens djurpark. And yeah, the D needs to be included in organization. But you can have some sympathy for the model in some of these cases, basically. Okay, let's continue. Application to transaction categorization. So as I discussed before, Tink has existing models for transaction categorization. And we wanted to see if we can apply our named entity recognition model to these transaction categorization models, to see if we could improve them. And our general hypothesis was that, okay, if a transaction categorization model would know that this part of the transaction description, this is an organization, this part is a location, etc., etc., then they would make more accurate predictions, basically. So we used two different approaches. One was we used named entity recognition for pre-processing, cleaning the transactions by removing unnecessary information. That was the first approach. Second approach was we developed a multi-input model where we combine the transaction categorization model with features from our named entity recognition model. So, and these are the baselines which we use to compare. And it's weighted mean KPI score, which is a Tink metric. It also goes from 0 to 1, with 1 being better. And they have two different models, one called FastX, one called XGBoost. And these are the metrics we compare to. Okay, so named entity recognition for cleaning the data. This was the first approach. Within this approach, we have two different approaches. First one is we try to see in the transaction description if we can find an organization. If we find an organization, we keep it, we remove the rest. If we don't find an organization, we look for MISC, if we find, which is payment provider, etc. If we find that, we keep it, we remove the rest. If we don't find any of these two, we keep location and person and clean away the rest. If no named entities are found, we keep the original transaction. Second approach is just we keep all named entities and discard the rest. If we don't find any named entities, we keep the original transaction. And for the first approach, you can see how it looks here. So here you have transaction descriptions, and then after the first approach is applied. So you can say first example here, it finds Ham Shop, which is an organization. So it keeps it, discards the rest. It finds ÖoB, which is an organization, keeps it, discards the rest. Here it finds a payment provider and an organization, so it keeps the organization. In this case here, it doesn't find anything, so it just keeps the original transaction, etc., etc. So as you can see here, it looks super clean, but it ends up not being that useful for transaction categorization. And both of these approaches end up performing worse than the FastX baseline. First approach by 1.5% and second approach by 2.4%. So what happens is that you basically remove too much information. It could be the case, for example, that you have a word like hyra being included in the transaction, and the hyra is rent, but that's not a named entity. But as you can imagine, that's a very predictive word in determining if a transaction is rent or not, basically. So what did we do instead? We instead of removing information, we look to see if we can add information instead. So we use the Tink categorization model as it is, and then we add some things to it. And it's basically the middle part and the right part here, which we add. So what we do is we get the transaction description coming in. This is then pre-processed. Our named entity recognition model finds the named entities. In this case, it's Convic, which is an organization, and Kista, which is a location. This is then tokenized, which means that we break the text into smaller components. And these hashtags here are to say that this is not the start of a word, basically. So these three belong together. So Convic here, and these are tagged as organization. And then you have Kista, which is a location. The CLS and the SEP here, this is to say that this is start and end of text. And the padding here is to handle different lengths of transactions, basically. So these are then encoded, and basically machine learning models, they can't handle text, so you need a numeric representation. So these are all vectors, and this I've taken from the second last layer, the hidden states from the transformer model, which I used for my named entity recognition. And on this part here, we have used just the one-hot encoding, which is just orthogonal vectors, since, yeah, there's not that many alternatives here. There are just a couple of different tags. Okay, so this vector encoding, which I have produced, together with a 45 long probability vector, a probability of each category, basically, from the think model, plus a possible amount, these are all then sent into a 45 node dense layer. And then the category is predicted. And in this case, it's communication. So this is what it looks like. Okay. So embedding squashing, this is something cool I did. So this is to turn my subword embeddings into entity embedding. And you do this to reduce padding, basically. If I just go back here, I said padding here, this is to handle different lengths of transactions. And the transaction descriptions, they can vary a lot in size. It can go all the way from 1 subword up until 17 subwords, if you break it down on a subword level like this. So for example, in this case, if it can go up to 17 subwords, we need to pad it so it can handle up to 17. So it means we have 17 vectors here, and essentially only 4 of them are useful, and the rest is not useful. So how can we reduce the not useful part? And this is what I do here. So if we have, for example, a transaction description being ICA Maxi Stormarknad Västra Skogen, then my named entity recognition model finds that ICA Maxi Stormarknad, that's an organization, Västra Skogen, that's a location. And here they are broken up in subwords. And then each subword is assigned an embedding, basically, just as in the last image. But you can say this is 8 subword embeddings. But instead, we take the mean embedding for all the subwords within the named entity here. So ICA Maxi Stormarknad gets 1 embedding, and then Västra Skogen also gets 1 embedding. And as you can see here, we cut the amount of the vector size in 4, basically, when we do this. So you do lose some information in this process, but you reduce the padding by a lot. The maximum size you reduce by more than 50%. So the overall net effect is positive. So this was something cool. Okay. So this was the results from our multi-input model. When we ran the model 5 times, we got the following mean, which 0.793 in weighted mean KPI score, and you have a bit of a confidence interval there. And this was 7.4% above the fast text baseline and 1.1% above the XGBoost baseline. So we proved that we could improve transaction categorization by including our named entity recognition model, basically. So here you have a detailed breakdown on the different performance metrics that Think uses. But yeah, I'll continue. So conclusions. What did we do? We annotated a data set of 3,200 transaction descriptions. We developed named entity recognition models on transaction descriptions, with our best model reaching an overall F1 score of 0.849. And this was despite only using 2,200 transactions for training. And to the best of our knowledge, this will be the first published report on named entity recognition on transaction descriptions. And we also showed that using our named entity recognition model, we could improve transaction categorization. And yeah, some topics for future work that I think would be interesting to dive more into is entity linking and transformer models for transaction categorizations. I won't go into it now, but you can read about it in my report. And yeah, that's basically it for me. I want to thank Trent Woodbury and Per Pierre Nugs, which was my supervisors for this thesis, and also Tink for taking me on and supplying me with the necessary resources. Thanks.